Hey, it's Coach Reeves here. I'm here to help you go through Review 2.2 and get you ready for the test. Okay? I'm going to work about half the problems on the review, so hopefully this will give you a good idea of what to expect. All right, so let's get started. On number one, they're going to ask me to find the axis of symmetry. I've written the equation for you to set it up for you. So we're going to say x equals the opposite of b. Well, this is my a value, this is my b value, this is my c value. So the opposite of b, the opposite of a negative 32 is a positive 32 over 2 times my a value. My a value is a negative 2. This is going to give me x equals 32 over negative 4. X equals negative 8. Now the axis of symmetry is actually a line. So you need to write your answer as an equation of the line. It has to have an equation. So it's going to be x equals negative 8. You need to remember this. It's got to be an equation. Okay? This problem, they're going to ask you to find the vertex. Now I'm going to show you how to find the vertex by hand. In a couple of problems, I'm going to show you how you can use the calculator to find the vertex. But right now, let's do it by hand. Okay? So we're going to use that same formula of x equals the opposite of b over 2 times a. We're going to use that same formula we just got through using. There's an invisible 1. This is my a. This is my b. This is my c. So we're going to say x equals the opposite of my b. The b is a negative 4, so the opposite would be a positive 4. 2 times my a value. My a is a 1, so we put a 1 right here, and that's going to be 4 divided by 2. You're going to tell me that x equals 2. Now the vertex is an actual location on your graph, so it's an ordered pair. So the vertex is going to be 2, and now we need to find the y value. Okay? So we're going to take this x value and we're going to substitute it. We're going to substitute it right here where this x is and where that x is. So we're going to say that y equals someone squared, whatever our x value squared is, minus 4 times the x plus 10. So the value that we're going to substitute in is a 2. So we're going to put a 2 here. We're going to put a 2 here. Y equals 2 squared is 4. Negative 4 times 2 is a negative 8 plus 10. Now when we combine like terms, that's going to give me a negative 4 plus 10. And you're going to tell me that y equals 6. There's the second half of my answer. Y equals 6. There's the location of your vertex. So what are you going to do? You're going to use that same equation you used to find the axis of symmetry. You're going to find your x value, and you're going to substitute it into the equation, and you're going to solve for the variable y. And there's your vertex. Okay? Next problem. They're going to ask me to find the x-intercepts. Okay? In the future, we're going to show you multiple ways to find the x-intercepts, but we're going to take care of you today. We're going to show you how to use the calculator to find your x-intercepts. And x-intercepts means where does my graph touch the x-axis? Okay? All right, let's look at this. We're going to use the calculator, so when we pull up the calculator, this is our equation for number 5. Okay, so we need to input this in the calculator. So we're going to say parentheses, and we're going to say x plus 2, x plus 2. We need to get outside of the parentheses, and then we need to square it. So you have x plus 2 squared minus 1. And we hit enter. Now you can see my graph right here. My graph touches at -1 and -3. -1, and -3. Now these are actually locations on the graph. It is preferred that you write them as an ordered pair. Sometimes you may see them listed as -1, -3, depending on if they're going to say, hey, these are solutions, these are zeros. All those certain terms mean the exact same thing, okay? If it's an x-intercept, that means it's a location. You probably need to write it as an ordered pair. But if they say, hey, look for the solutions or the zeros or the roots, they all mean the same thing, and they'll probably just write their answer as -1, -3, okay? All right, let's go to another problem. They're going to ask us, after this, they're going to ask us to determine the range in interval notation, okay? Now again, we could do this by hand, but I'm going to show you how to find the vertex using the calculator, because you're going to use the vertex to find your range, all right? Let's go to the calculator. Let's get rid of this stuff. And we're going to start again. We're going to go home. We're going to get a new document. And we're going to graph. And we're going to put this guy in. We're going to put in number 7. Number 7, where they're asking us to find the x-intercepts. We're going to say 3x squared, 3x, and then they have a little square button, x squared, minus 18x, minus 18x, and then it says plus 21. And we hit enter. All right, so we're looking for this vertex. Now, we already know the range. The range is going to deal with my y values. All right, what happens to my y values? Well, they're going to start down here, and they're going to get bigger, okay? But I need to find this location. I need to find this vertex, okay? So I'm going to ask you to go menu. I'm going to write this down. We're going to ask you to go menu. Not going to leave you here, okay? Let me erase that. It doesn't work with the pen. We're going to say menu. We're going to ask you to analyze this graph, okay? We're going to analyze the graph. Let me write this over here. Analyze graph. We're going to look for, what we're going to do, we're going to look for, it's either a maximum or a minimum with our vertex. And since we're opening up and my vertex is way down low, we're looking for the minimum. So we're going to say, I want to find a minimum in this case. I'm going to say min or max, depending on our graph, okay? And you see this says, I've got a broken line, but over here to the bottom left, it says the lower bound. That's the lower boundary. They're going to ask you the lower boundary to move to the left of where you think the vertex is. So we're going to move our broken line to the left of where we think the vertex is. And then it changed to upper bound. They want you to move it also, when you click, move it to the right. And it tells me my minimum is at 3, -6. There is my vertex. The low point of my graph, is at 1, 2, 3, 4, 5. This tells me the low point of my graph right there is at a -6. The y value is how low I go. So the lowest point of my graph is at -6. The high point of my graph is going to go up forever, which is going to be infinity. There is the range for your graph. Now, think about this. If I gave you a graph that opened downward, it would go down forever, and it would be -infinity on one side, and then you'd have to find the maximum, the highest y value for the other one. Okay? All right, let's move forward. So we have found the range and the interval notation. Now we're going to ask you to list the transformations. This is simple. This is the same thing we did with absolute value. Okay? But remember, if a transformation does not occur, then we don't talk about it, we don't list it, we don't write it. Okay? So look at our problem. On number 9, I have a negative sign. I have a negative sign right there. So that tells me that I'm going to have a vertical reflection. and then I have a fraction. This fraction, right here, that fraction, since it is less than 1, the absolute value is less than 1, it's a vertical compression. So we're going to have a vertical compression by a factor of 1/2. Now the tricky part is this right here. Look, it's not in parentheses. Normally we'll have parentheses and we'll have somebody squared, and then I'm going to ask you to take the opposite. But there's nothing in parentheses here. What this really is x minus 0. That's what's in there. And that's why it's just x squared. Because x minus 0 is just x squared. So we did not go left or right at all because it's a 0. So we do not have a horizontal shift. So we do not talk about it. We don't list it as a transformation. But what we will talk about and what we will list is my k value at the back end. This will give me a vertical shift up 6. Those are your transformations for that problem. Okay? Let's try another one. Here they're going to ask you to write the quadratic equation using the transformations. Okay? So the transformation, well, we know it's going to be y equals, let's see, I have a vertical reflection. Because I have a vertical reflection, that tells me that I'm going to have a negative sign or a minus sign at the front. Okay? Then it says that I'm going to have a vertical stretch by a factor of 5. So that means there's my vertical stretch. It says here I have a horizontal shift, and I'm going right to. I have a horizontal shift, but it says I'm going right to. And remember, when we talk about these horizontal shifts, we're thinking the opposite. So we would think that right to is a plus, but remember, we're thinking opposite, so that's going to be x minus 2. And then we have a vertical shift up 3, so we went plus 3 at the back end. There is your quadratic equation using the list of transformations. Okay? All right, moving forward. On number 14, they're going to ask you to list a transformation and write a quadratic equation. Okay? Two things. I'm going to write the quadratic equation first. Okay? And then I'm going to list my transformation. I just think it's easier that way. This point right here is my vertex. Okay? That is my vertex. So I'm going to say y equals, I'm going to leave a little bit of space so I can figure out my a value in just a second. But this graph, look what I've done. I have shifted 1, look how we're counting, 1, 2, 3, 4. I have shifted to the left 4, and we're thinking opposite, so I'm going to say x plus 4 squared. Do you understand? Okay? And then I've gone what? I've gone 1, 2, 3, 4. I have gone up 4. So just by looking at my vertex, I know that I have shifted to the left 4 and I have shifted up 4. My graph is opening downward, so that's going to give me a negative. Now here's the part that your teacher went over with you, and you should remember the pattern. The parent function pattern for a quadratic is 1 squared is 1. 2 squared is 4. That pattern of 1, 1, 2, 4 is the normal. Okay? So look at ours. We're right here. I'm asking you to look at this. We're going to go 1, 1. 1 squared is 1. 2 squared, 1, 2. 2 squared is 1, 2, 3, 4. This is where the normal pattern is. I should be right here. But my graph is not there. So what does that mean? Is that going to be a stretch or a shrink? Okay? Well, I should be right here. I'm not where I need to be. I'm a little bit shorter. I'm less than where I need to be. Here, I should be at, let's look at it, I should be at 1, 2, and then 1, 2, 3, 4. I should be here, but I am only halfway there. I am half as long as I need to be. So that means you have had a vertical compression by 1/2. Instead of going 1, we're halfway there, or instead of going to 4, we're at a 2. There's you're going to have a half as far as your A value goes. There's your equation. So what are we going to do? We're going to list our transformations. We have a vertical reflection. The negative gets us a vertical reflection. We're going to have a vertical compression by 1/2. We're thinking opposite here, so we're going to have a horizontal shift. In this case, we're going to go which way? Now look at the graph. The graph said to go left 4. And then we have a vertical shift up 4. So there's your equation, and there is your list of transformations. Okay? All right, let's try another one. List the graphs in order of smallest to largest A values. Now you got to think, the bigger the A value is, like if your height is like 2, 3, 4, 5, that means you're going to have a vertical stretch and you're going to be skinny. The smaller your A value, like 1/2, 1/4, 1/8, the flatter and wider you're going to get because it's a vertical compression. So they're asking you to find the smallest A value. The smallest A value will be the widest or flattest graph. Think about what you have here. I'm looking at, now it's the absolute value. The negative part only means you're opening downward. We're talking about the absolute value of A. So look at this. This is over 1, up 1. That's a half. Over 2, just like the problem we just did, my A value here, my A value is 1/2. Look at this one. Over 1, up 1. Over 1, up 1. Over 2, up 4. This is normal. My A value is 1 right there. Here, I'm going to go over 1. Instead of going up 1, I go over 1 and down 2. So my A value is a 2 here. Over 1, down 1, 2, 3. My A value is 3 here. So where's your smallest A value? It's going to be graph C, then graph B, then graph A, and then graph D. Even though this is opening downward and you're thinking that's negative, it makes it smaller. That's not the case because we're looking for the absolute value of the A value. Okay? All right, so that's how you do these. On number 17, Pamela puppy sits for an hour, or for $4 an hour. She also works as a tutor for $10 per hour. She is only allowed to work 10 hours per week. She wants to make at least $70. Write a graph of system of equality. Write and graph a system of inequalities. Be able to determine an ordered pair, or if an ordered pair is a solution. So here we go. I'm going to say that X equals her job as a puppy sitter. I'm going to say that Y equals her job as a tutor. So we're going to set up an inequality. We're going to set up the system. All right, so if we take all of her hours, all the hours that she is a puppy sitter, and we add it to all the hours that she is a tutor, it says that she is only allowed to work for what? 10 hours per week. So we're going to say less than or equal to 10. We're going to need to graph it. We have to graph that. So in order to graph that, we're going to move the X to the other side, and we're going to subtract, and we're going to get Y is less than or equal to a negative X plus 10. So what does that look like when you graph it? Well, There's your y-intercept at 10. We're going to go down 1 to the right 1, down 1 to the right 1. Over here, down 1, right 1, down 1, right 1. We're going to end up right there. We're going to have a line that looks like this. It says less than or equal to. So we're going to shade on this side. We're going to shade down here in this area. The next inequality says she gets $4 per hour. So for every hour that she puppy sits, $4 for every hour that she puppy sits. Plus, she gets $10 for every hour that she tutors. And she wants to make at least $70. So this is going to be greater than or equal to $70. We need to move, let's move this just a little bit. I need to get y by itself, so we're going to move the 4x. We're going to get 10y is greater than or equal to a negative 4x plus 70. We're going to divide by 10. And what this is going to get me, the inequality of y is greater than or equal to, I can reduce this fraction to a negative 2 over 5x plus 7. So if I go and graph that, let's graph that in a different color. I start at 7. 1, 2, 3, 4, 5, 6, 7. My slope says to go down 2 to the right 4. Right 5. 1, 2, 1, 2, 3, 4, 5. Down 2, 1, 2, 3, 4, 5. I will have a graph that looks like that. It says greater than, so we're going to shade above it. So the overlap is going to be right here. There's an overlap, okay? Now what you need to be able to do is what I just did. You have to graph this, okay? And what's going to happen is we're going to give you ordered pairs, and we're going to ask you which ordered pair is, or maybe which ordered pair is not a solution. Now, look at this. We have a bar. We have a bar underneath. We have a bar underneath. That's why we have solid lines. But this time, if my point is right there at that intersection, is that a solution? Yes. There are not any broken lines anywhere right now. That could be a solution. Anything on a solid line or in the shaded region would be a solution. Okay? Remember that when you get the test question. Okay? All right, moving forward. We're going to have to set up a system of inequalities. Okay? Mario is doing a fundraiser for school. He needs to sell at least $200 worth of shirts and hats. Okay? It says the shirts cost $10 each and the hats cost $8 each. He must sell more than 12 hats. Okay? Well, let's say this. We're going to say that X equals shirts. Y equals hats. Alright, so it says he needs to sell $200 worth of items. So how much is for the hats? These are the hats. How much is each hat? Each hat is, this is the shirt. X's are the shirts. It says the shirts cost $10. So for every shirt, we're going to multiply times 10. For every hat, our hats are Y, we're going to multiply times 8. And if you take all your shirt money and all your hat money and you add it together, it needs to be at least $200. $10 for the shirt, $8 for the hat. We need to make at least $200. And then it says he must sell more than 12 hats. There's his hats. Wise. Your hats must be what? More than, doesn't say equal to, does it? It doesn't say at least 12. He says he has to sell more than 12 hats. So my hats has to be greater than 12. There's your system of inequalities. Okay? All right, next problem. All right, the school that James goes to is selling tickets to a fall musical. On the first day of ticket sales, the school sold 7 senior citizens and 4 student tickets for a total of $144. These are kind of the easy problems you'd like if you're going to get a word problem. Okay? So what we're going to do is we're going to look at our two topics. We have senior citizens and we have student tickets. We're going to say that X equals the senior citizen or the senior tickets. We're going to say that Y equals the student tickets. Okay? So we look at the first equation we have. It says 7 seniors and 4 students, okay, for a total of $144. In the next sentence, it says it took in $192 by selling 1 senior citizen ticket and 12 student tickets. And there's your 192. Now, again, you could solve this by elimination if you wanted to, but we have shown you how to use your calculator to do this. And when you put this in your calculator as a system, you're going to get this as your X value and this as your Y value. This will be the cost of a senior citizen ticket. This will be the cost of a student ticket. Okay? So what are they going to ask you to do? It says, you got to read this. What is the price of what? 2 senior citizen tickets and 2 student tickets. You have to add that together and give me a total cost. 2 of these, you're going to have to go 12 times 2, and then you're going to have to go 15 times 2. 2 senior citizen tickets is $24. 2 student tickets is going to be $30. You add those together and you're going to give me a total of $54. This is what they're asking for. Make sure you read the problem all the way through and see what they're asking you at the end. Don't just stop when you find your X and Y value. Make sure you answer the question that they're asking. Okay? Next problem. You're going to have to think a little bit on this one. It said, Miss Hallen's restaurant ordered 200 flowers for Mother's Day. They ordered carnations, roses, and daisies. Now that's misspelled. Okay. The carnations were $1.50 each. The roses were $5.75 each. And the daisies were $2.60 each. They ordered mostly carnations and 20 fewer roses than daisies. The total order came to be $589.50. How many of each type of flower was ordered? Here's the hint. It's going to be 3 equations. Have we showed you how to use the calculator to solve a 3-equation system? Yes. Okay? So let's think about this. Let's set up our system. So it's going to be 3 equations. Okay? The first one, it says, we're going to say that X equals carnations. The next one, we're going to say that Y equals roses. And then we're going to say that Z equals daisies. So we have a total of 200 flowers. A total of 200 flowers. So if you take all your carnations and you add to it all the roses and you add to it all the daisies, that will be a total of 200 flowers. There's your first equation. Carnations plus roses plus daisies will equal a total of 200. Now we're going to put a dollar figure or a dollar amount to it. How much is it for a carnation? The carnations are $1.50. So it's $1.50 for every carnation. Plus, look at the price for a rose. $5.75 for each rose. And then the price for a daisy. The daisies are going to cost $2.60 each. So we're going to say plus $2.60 for each daisy. How much total money was the order? $589.50. So when we start putting a dollar amount, then our answer needs to be a dollar amount. But when we're talking about just how many of flowers we have, then we use the total number of flowers. We need one more equation. Where's it going to come from? This is the tricky part. They ordered mostly carnations. This is a distraction. Who cares? The key is this right here. And 20 fewer roses than daisies. 20 fewer roses than daisies. Okay? So you have roses and daisies. We have roses and daisies. Who do you have more of? Let me move this just a little bit. Who do you have more? Well, it says fewer roses. There's more daisies, right? Well, we want them to be equal, so if there are fewer roses, we're going to subtract 20 from the daisies to make them equal. There are already a smaller amount of roses, so we're going to take 20 from the daisies to make them equal. There's 20 fewer roses than daisies. There is your system of equations. 1, 2, 3. And if you put this in the calculator, this is what it's going to tell you. X, Y, and Z, or there are going to be 80 carnations, 50 roses, and 70 daisies. That's how you solve this system of equations. Okay? That's it. I got nothing else. That's about half of your problems on your review. Okay? There may be a couple that are going to bother you. You get stuck. Hopefully you attempt your review before your test, way before the night before the test, so you'll have time to ask questions during a Zoom meeting or maybe email your teacher. All right? Hey, good luck, but always, if you have any questions, please contact us and let us give a chance to help you. Okay?